All right, here are solutions to the trig equation worksheet from today. The basic idea on here on all of these is you're trying to solve equations. You're trying to figure out what values x could be so that the left side of the equation is the same as the right side of the equation. It's challenging to do though because you have these trig functions inside here. However, the tricks that you will do will be very similar to the tricks that you would do if you did not have the trig functions. So in this first example, I have something minus something else equals 0. And generally speaking, that's not a good form to be in. You'd much prefer it was something times something equals 0. Because multiplication has this nice property that the only way you can multiply two numbers together and get 0 as the product is if one of those two numbers are themselves 0. So how do you change a subtraction problem into a multiplication problem? You factor. And so I'm going to be doing a lot of factoring. In fact, it'll be almost exclusively what I do on this worksheet. In this first one, you'll factor by finding the greatest common factor. Both terms have a sign of x in them. So I can pull out a sign of x. If I pulled out a sign of x in this first term, what I would have left would be 2 times cosine of x. And from this second term, I would have a square root of 2 left. And so what I now have is something times something equals 0, which is a great form to be in, because the only way you can multiply numbers together and have the product be equal to 0 is if one of the two factors equals 0. I'm going to be saying that a lot in this video, so sorry if it's annoying already. This times this equals 0 means either this equals 0 or this equals 0. And now I can solve. How do you solve this for x? Well, I guess you could take the arc sine of both sides of the equation, but that'd be a little bit tricky because you want to make sure that you get all the solutions that fall in this range, and arc sine will just give you one solution. I think it's easier to just think about it at this point, to kind of stare at this. What angles, so think in terms of your unit circle, have a sine equal to 0? The sine of what angles equals 0? Well, on my unit circle, I remember the sine was the height, the y-coordinate, and the height is 0 at 0, and at pi, and at 2 pi, and at 3 pi, and at 4 pi, and at negative pi. Yeah, all those are right, but you're only going to write 0 and pi because we only want the solutions in this specified range. You might not know what angles, once you take their cosine and then double it and then subtract the square root of 2, leave you with 0. But you could solve this. You could add root 2 to both sides of the equation and then divide by 2 and get cosine of x equals root 2 over 2, and maybe then you'd be able to reference your unit circle and figure out what values have a cosine and x coordinate equal to root 2 over 2. Well, that happens at pi over 4 and at negative pi over 4. True, but we only want 0 to 2 pi. So instead of negative pi over 4, I'm going to reference 7 pi over 4. Those points are coterminal, but this one will be in the specified range. So I got x equals, I'm just making it worse, pi over 4 and 7 pi over 4. And these 4 would be my solutions. A note on notation is on a quiz or on any time you're asked a question in this form, which WebWork will do primarily, you just type them in like this. However, you'll occasionally see questions that say, maybe I'll even write this, if asked for all solutions. So not just all solutions in this range, but all solutions, period. Then what you got to do is say, well, not only is 0 a solution, and pi over 4, and pi, and 7 pi over 4, those are all solutions, but if I add 2 pi to any of those angles, I'll get another solution, because adding 2 pi to an angle makes no difference. I can always add or subtract any multiple of the period of the functions that produce these answers. So the period of both sine and cosine are 2 pi, so I could do plus or minus as many 2 pi's as I want. The way you represent as many 2 pi's as you want mathematically is you say 2 pi k. K is assumed to be a whole number. So I would end up with solutions that look like this instead. If it asks for all solutions, which it does for some problems, but primarily they're asked in this form here. I wrote them in this order, 0, then pi over 4, then pi, then 7 pi over 4, because I believe our homework system wants them written in ascending order, and it should tell you as much. All right, moving on. Number 2, tangent of x minus 2 sine of x equals 0. Oh, again, it's the subtraction. I want it to be multiplication, so I factor. Yeah, that's true, but you might stare at this and be like, how the hell am I going to factor? I don't have anything in common between these guys. This one doesn't have any sines. This one doesn't have any tangents. What am I going to factor? Well, the trick will be rewriting tangent as sine over cosine. Because now all of a sudden both terms do have a sine of x in them. I can factor out that sine of x from each of these terms, and what I would have left would be 1 over cosine of x minus 2. And now I've changed it from a subtraction problem into a multiplication problem. Something times something equals 0. That's awesome. If something times something equals 0, one of those two somethings, to speak as informally as possible, must be equal to 0. So change this from one equation into two equations and then solve the equation. Sine of x equals 0, done. Right, we did that earlier. That happens when x equals 0 or pi. Or 2 pi or 3 pi, right? But we only want answers in this range. This one's hard. 1 over cosine of x minus 2 equals 0. Well, you could change it to secant of x and add 2 to both sides. When does secant of x equal 2? Oh, you might not know. Okay, if I wanted to avoid secants, I could stick with cosines. I could maybe add 2 to both sides of the equation to get 1 over cosine of x equals 2. And then multiply both sides by cosine to get 1 equals 2 cosine of x. And then divide both sides by 2. Now I got cosine of x equals 1/2, and that I can deal with because I know on my unit circle the x coordinate is 1/2 at pi over 3 and negative pi over 3. But again, because of the specified range, I'm going to refer to those angles as pi over 3 and 5 pi over 3. So I would have 4 solutions that fall in this 0 to 2 pi range. Throw a box around those and call that good. This one gives people a lot of trouble. The idea is you want to factor. We're not going to factor a greatest common factor like we did in 1 and 2. We're going to factor this as a quadratic trinomial. What I mean by that is you're going to think about this problem as though, I guess that says think, as though it were 6x squared minus 7x minus 5 equals 0. What would you do in this case? Well, you might think add 5 and then factor an x. No, you can't do that. It won't help you to factor if you add 5 to both sides of the equation, because it only helps to have a factored form if it's set equal to 0. If you add 5, it won't be set equal to 0. So you're going to have to do a different strategy. You're going to have to factor this quadratic trinomial. There's at least 2 ways to do this. A way that most people learn how to do this is kind of this guess and check method. Put numbers here and here so that when I multiply them together, I get 6x squared. How do you know if it's 6x and x or 3x and 2? You don't. Guess and check. And then put numbers here and here that multiply to give me negative 5. Well, let's see. Negative 5, positive 1. Positive 5, negative 1. In which order do I put them? I don't know. Guess and check. Keep guessing until when you FOIL it all out, you get the original. Turns out that this will work. Nope, that won't work. Turns out that this will work. But how the hell did you know that? I mean, yeah, it's easy to know it if you write the problem. I mean, go through and FOIL it out. You get negative 10x plus 3x, which nets to negative 7x. Negative 5 times 1 is negative 5. Great. If I know the answer, I can find the answer. But what if I don't know the answer? If you don't want to do this guess and check method, which works perfectly, here's another method, which admittedly is a little bit longer, but it'll work. It's a 3-step process. Step 1 is you're going to find 2 numbers that add to the coefficient on your linear term. In other words, they add to b. They add to negative 7. Whatever number's in the middle here, this negative 7 is what you want them to add to. And then they have to multiply 2, and you're like, oh, slow down, I got this. They multiply to negative 5, right? I've seen this before. No. They multiply to negative 30. Where the hell did negative 30 come from? It's a times c. It's this 6 times this negative 5. It's the product of the constant term and the coefficient on the quadratic term. It's the 6 times the negative 5, gives you negative 30. So stare at that for a while and find 2 numbers that add to negative 7 and multiply to negative 30. If you struggle with that, think of all the numbers that multiply to 30. 30, 1 times 30, 2 times 15, 3 times 10, 5 times 6. I think I got them all. Oh, but I want it to be negative 30, so one of those 2 has to be negative. So make one of those negative, one of them positive, and add to negative 7. I think the only way you'll do that is if you choose negative 10 and positive 3. That's all step 1. Step 2 is to replace your linear term, in other words, the negative 7x, with negative 10x plus 3x. Okay, negative 10x plus 3x is negative 7x, so that seems like a fair substitution to do. Where the hell did that come from? From step 1. Those numbers there, they become the coefficients down here. So, okay, now I got 6x squared minus 10x plus 3x minus 5 equals 0. That's not factored. True. But now I have 4 terms, and the way these terms are, this will always work as factoring by grouping. Step 3 is to factor by grouping. So to factor by grouping, you make 2 groups. The first 2 terms become your first group, and you look for the greatest common factor in the group. So what do those guys have in common? Well, they both got an x. Wait, they both have a 2x. Yeah, they both got a 2x. Their greatest common factor is 2x. Factor that out, you're left with 3x minus 5. Then stare at your next group and factor out something so that you'll be left in the parentheses with the same thing you got here. Well, in this case, I already have 3x minus 5, so I just factor out a positive 1 as a placeholder. That won't always be the case. You might not have a 3x minus 5 here. You might have a 9x minus 15, in which case you'd factor out a 3 to be left with 3x minus 5. In this case, I just pulled out a positive 1 as a placeholder. What I now have are two terms. This whole thing is one term, this whole thing is the other term. And they both have a 3x minus 5 in common. So I can factor out that 3x minus 5. This isn't there anymore, neither is this. What is there? The 2x and the plus 1. That's what's called factoring by grouping. That's how you factor this quadratic trinomial. Unfortunately, that's not the question that was asked, but it's very similar to the question that was asked. I can use the same method to factor this guy. I would say that 6 sine squared x minus 7 sine of x minus 5 equals 0 is equivalent to 3 sine of x minus 5 times 2 sine of x plus 1 equals 0. Those factoring steps, do them again, except now instead of x, it's sine of x. Something times something equals 0, that's good news. 3 sine of x minus 5 equals 0, or 2 sine of x plus 1 equals 0. So either 3 sine of x equals 5, in which case sine of x is equal to 5/3, or 2 sine of x equals negative 1, in which case sine of x is equal to negative 1/2. Negative 1/2 you might have memorized off your unit circle, 5/3 you don't. Not only is this not a memorized value off your unit circle, this doesn't even exist on your unit circle. The sine function has as its range values from negative 1 to positive 1. We can't get things out of the sine function that are bigger than 1. 5/3 is bigger than 1. There are no solutions to this equation. Not to the original equation, but to this equation right here. This does have solutions. There are angles so that the sine of that angle is equal to negative 1/2. That happens at pi over 2 pi over 3. And then that happens again at 4 pi over 3. No, that's not right. Damn. That happens at 4 pi over 3. That's not right either. Jeez. That happens at 7 pi over 6. That is right. And 11 pi over 6. Those are the two spots on your unit circle that will have a height of negative 1/2. So these end up being the only two solutions because I didn't get any solutions from this side because sine's never equal to 5/3. Finally, this last one for this video, I'll do the remaining ones in a different video because it's getting kind of long. How the hell am I going to factor this? I got sines in one of them and cosines in the other. Like it kind of looks like this guy. It kind of looks like a quadratic trinomial, but I have different variables. One's sine of x and one's cosine of x. So it would be as though I had 6x squared minus 7y. So how am I going to do that? Well, fortunately, trig functions have this nice property that you can change sines into cosines and cosines into sines. It's easiest when they're squared. If I added 1 to both sides of the equation, I would have 1 minus sine squared x plus cosine of x equals negative 5/4 plus 1. And I added 1 to both sides. But 1 minus sine squared x is just equal to cosine squared x using the Pythagorean identity. Sine squared plus cosine squared equals 1. So 1 minus sine squared equals cosine squared. Negative 5/4 plus 1 is negative 5/4 plus 4/4, which is negative 1/4. You're like, oh, and then factor out a cosine of x. No, don't factor when it's not equal to 0. It won't help you. That's not specific to this class. It'll never help you. When you're trying to solve an equation, set it equal to 0 before you factor. Sorry if I sound angry. It's just people always make that mistake, and I'm trying to help. And I'm sick, and I want to be done with this video. Add 1/4 to both sides so that it's set equal to 0. And now it helps to factor. A little bit annoying factoring when you have fractions. You're looking for two numbers that when you multiply them together, you get 1/4. And when you add them, you get 1. It turns out that 1/2 and 1/2 are the solutions to that. So this will factor like this. But wait a minute, those two guys are the same. So if cosine of x plus 1/2 equals 0, I can just solve one of them, right? It'll be the same answers I'd get for this one. And we can solve that by subtracting 1/2 from both sides of the equation. And then thinking about your unit circle. Where is the x coordinate equal to negative 1/2? That happens at what, 2 pi over 3? And again at 4 pi over 3. Those are right. So those end up being the only two solutions to that equation. And so I'm going to stop this here and make another video for the remaining problems on this worksheet.